Hello. Hopefully everybody can hear me today. I got a little error when I tried to load my stream. So hopefully it's working. Can you hear me? Question today is, which professional athlete would you want to work out with? Professional athletes are incredibly fit, and if you had to pick one of them to be like your personal trainer, who would it be? So again, I had some issues. Hi, me Zorn. Hey, Diamond, can you hear me? I had an issue when I loaded my stream here. Got a little error. Not sure if it's working right now. Can you hear me okay? Can you hear me okay? Hello? Okay, awesome. So the question of the day is, which professional athlete would you want to work out with? So remember, professional athletes, they're like ripped. If you had to pick one to work out with, who would you want to work out with? Like personal trainer. If you could pick any athlete, who would you want to work out with? That's the question of the day. So I will give everybody 3 minutes to jump in before we get rolling. I also want to remind you that tonight at midnight we are doing a Zoom meeting for all of my classes. I've been told that everybody sleeps during the day and is awake at night. So I know there's quite a few people that I haven't been able to connect with because they're on a weird sleep schedule. So I decided that I would try doing a Zoom meeting at midnight. We did one last week with the Astronomy Club and had 15 people show up at one point to do a stargazing party with us. So I thought it would be kind of cool to try that with my classes. Looks amazing outside today, but it's still freezing cold. Hopefully we get some warmer weather. My wife actually pointed this out to me this morning. Let me pull this up. See if it's still there. So let's see. I live in Plainfield. Yeah, so I saw this morning. This kind of freaked me out a little bit. There's a winter weather advisory. Look at this. From 11 p.m. this evening until 1 p.m. on Friday. 3 to 5 inches. 3 to 5 inches of snow. What the heck? It's like summertime outside and it's snowing again. Why? Why is this happening? I can't explain it. I don't have a scientific explanation for that. It's terrible. LeBron James, yeah. LeBron James would be a good person to work out with. He's huge. I got to sneeze. Ugh. So, yeah, man, LeBron James is huge, isn't he? Isn't he like 8 feet tall? Let me see. LeBron James height. He is 6'9". So I'm 6'2", so that's like a whole half a foot more. What's going on, Sarah? Sarah, are you going to jump on tonight and Zoom with us at midnight? It's going to be amazing at midnight. My wife is very upset with me that I'm holding a Zoom meeting at midnight because she thinks it's going to mess up her sleep. So we have to be really quiet when we're Zooming at midnight. So, Sarah, if you could pick a professional athlete to work out with, who would you want to be your personal trainer? Give about another minute, and then I will share mine with you guys. I got a good one. You'll probably never guess this. One of my favorite athletes of all time. And if it were only like 80 degrees, today would be like perfect. All right. So it is officially 1:03. I'm going to go ahead and get rolling here. If you want to share in the chat which athlete you would want to work out with, feel free. But I picked Mr. Frank Thomas, the Big Hurt, was one of the greatest White Sox players of all time. Look at his arms. Like, look at this right here. That's huge. I don't know what the circumference of his arm muscles are there, but they're ginormous. Like his arms are probably the size of my legs. Like here's another look right here. Like his last couple seasons he played for the Oakland Athletics. We won't talk about that, but he used to play forever on the White Sox. He was a designated hitter and he was amazing. He's huge, this giant guy. But like look at his arms. I feel like look at this tiny little arm here. I feel like he could probably help me get pumped. I need all the help I can get. So he would probably be a good choice to help me work out with. And he played for the White Sox, which is my favorite baseball team of all time. So, you know, it would be awesome. We could talk about White Sox and how much the Cubs are terrible, and he could help me with my obvious lack of upper body strength. All right, for physics, this is what our week looks like. So you did a little bit of video learning on Monday and Tuesday with magnetism. Yesterday you were supposed to play with the PhET simulation. I kind of went through that a little bit during my live stream. And then today you're supposed to write the methodology for the lab that we're working on. And again, reminder, tomorrow morning or tonight at midnight is our Zoom check-in. So if you're able to jump in, that would be awesome. So my plan today is, for the live stream, for the physics portion at least, is to go through and write the methodology together. So Diamond, you're welcome to stick around. I'm not going to get to chemistry until 1:30, but I'm going to go through and write the methodology for the lab we're working on. All right, so let me go ahead and pull this up. And Sarah, if you want to open your OneNote, if you want to do this with me, I don't know if you did it already, but let me pull mine up here. All right, so here is our PhET simulation, and I'm going to open OneNote at the same time. Okay, so you were either testing the relationship between the voltage and the strength of the electromagnet, or the number of loops and the strength of the electromagnet. So here is our electromagnet, and you should have also watched the video that I gave you a little preview of yesterday where I was playing around with electromagnets. So you should already know the answer to this question, but we're going to prove it with a little bit of evidence. So first thing you need to do is you need to talk about your variables. So on my lab right up here, we need to make sure that we are talking about your independent, oops, what happened here? Our independent variable. Independent variable, remember, is what we are changing in the lab. And it depends which version of the lab you're doing. If you are going to be looking at the, where did my lab go? Oh, it's right here. If you're looking at the voltage, if you're changing the voltage, that would be your independent variable. If you're changing the number of loops, that would be your independent variable. So it depends which one you're exploring. Remember, you're not doing both. So let me go back to my lab right up here. So the independent variable is going to be the voltage in volts or the number of loops. All right, the dependent variable is what we're measuring, okay? And in our lab, we are measuring the strength of the magnetic field. So we're using our field meter, and we are going to be dragging this right onto our coils, and we're going to be reading the top line. So our dependent variable, what's changing in the lab, is going to be the strength of the magnetic field. Okay. Supplies for this lab. Let me just put gather supplies. Gather supplies. And the supplies that we're going to need for this lab are a battery. We need a wire. And then we need a electric field meter. Or, sorry, magnetic field meter. Okay, so these are all simulated. Okay, so step one. Rather, on this, it's like part 4. We are going to, if we're changing the voltage, we are going to set the voltage and place the magnetic field meter on the coils to measure the field strength. Okay, so setting the voltage, and then I should also put in parentheses, if you're doing the number of loops, set the voltage or number of loops, and place the magnetic field on the coils to measure the field strength. Okay, so really all you're going to do after that is just adjust voltage or number of loops, and measure field strength. I should also maybe put in here, record measurement on data table. Okay, that's it. That's all we're doing for the lab. Piece of cake. So your independent variable is going to be your voltage or the number of loops. The dependent variable, what we're measuring, is going to be the strength of the magnetic field. You need to get your supplies, which are from the simulation, the battery, the electric wire here, and then the field meter. You really don't need anything else. And then you're going to be setting the voltage or the number of loops. Place the magnetic field meter on the coils to measure the field strength as we had it in our simulation. And then you're going to record whatever it's reading here. Maybe we should clarify in our methodology that we're reading the top row. So let me just add that here. Read field strength from top row. Okay, so record the measurement from the top row and record that in your data table. And then you're just changing something. So change the voltage, record the measurement. Change the voltage, record the measurement. Or change the loops, record the measurement. Change the loops, record the measurement. Okay, so we're going to repeat this process 4 times. Repeat step 5, and oops, step, can't spell, step 5 until you have 4 unique data sets. That's it. So for the methodology, that's really all I'm looking for. It needs to be in your own words. You want to make sure that you're being specific about things. So don't just say, you know, the thing that we measure with, it's the electric field meter, or, you know, you're adjusting the voltage, you're not just adjusting the thing. So be specific. Make sure you identify your independent, dependent variable, and that's pretty much it. So for tomorrow is Friday, I am not going to be talking about anything on a live stream because we are doing our Zoom meeting instead. So what I thought I would do today is go through how to collect the data, because what you're going to be doing tomorrow, we're looking at the schedule, is we're going to collect our lab data. All right. So I kind of already talked about how to do this, but I'm going to take just a minute or two and go through it one more time. So in OneNote, you need to adjust your data table. So the independent variable is going to be the voltage, which is going to be measured in volts, or the number of loops. It's one or the other. Don't write voltage or loops. Just either do voltage or loops. You don't need to put them both in there. Dependent variable is going to be the magnetic field strength, and the units are B, I believe, or maybe it's G. Hold on. I think it's G. I think it's Gauss. Let me go back and check really quick. Yeah, it's the G. G for Gauss. Yes, I'm pretty sure that's right. I don't know why I'm spacing here. Okay. So that's going to be trial 1. And then you would do the same thing for trial 2. Trial 2, and then you're going to do the average. Okay, now I think it's worth mentioning, because this is a simulation, you are going to get the same number, whether you do it 1 trial, 2 trials, 3 trials, 100 trials. It's always going to be the same. So what I would do in your methodology, it does, I think, ask you to mention the number of trials. I would mention that only 1 trial is necessary because this is a simulation. Okay. If you do 2 trials, it's fine. I'm not going to ding you or anything, but I just think it's worth pointing out that this is a simulation, so it's going to be the same number every single time. You know, if we had, you know, actual batteries and we were doing this with an actual meter, the numbers might vary slightly. It might fluctuate slightly, so we might get different numbers. And anytime we're doing something like this in a lab where we get some sort of fluctuation, it's a good idea to average out our numbers to be as accurate as possible. Okay? So, Sarah, did you do voltage or did you do the number of loops? If you're still there, did you do voltage or the number of loops? If you haven't done any, just pick one, and I'm going to do that right now. We'll do it together. Voltage or number of loops? Voltage or number of loops? Oh my god, it's so nice outside today. I just wish it was warmer. Sarah, are you there? I think she fell asleep. She says number of loops. Okay, so what I'm going to do is I'm going to adjust this, and I'm going to do this based on the number of loops. So 1, 2, 3, or 4 loops, which I think are the only options you have. All right, and then let's go to the simulation. All right, hopefully that's not super small where you can't see it. Oops, that's not what I wanted. Okay, so for one loop, we get a reading of 75. And again, that's the same number for everything. All right, for 2 loops, we get 150. For 3 loops, we get 225. And for 4 loops, we get 300. I don't think you can go any higher than 4. Yeah, you can't go any higher than 4. Okay, so that's really all you need to do for data collection. If you were doing voltage, you would just pick 4 different volts. Okay, number of loops is kind of boring because you're stuck with 1 through 4. You can't go any higher than 4. Okay, but that is all you're doing for your data collection. Now Monday, we are going to get into some graphing. You'll have to graph this, which isn't too terribly difficult, but I posted a video. Actually, if you go to the very top of the page, if you want to work ahead, if you're feeling like gung-ho physics and you want to work ahead, if you click on this link, what is going on? I think my son is sucking up all of our bandwidth right now with Fortnite. There it goes. Okay, so if you click on the link at the top, it will bring you to this page on my website. So I basically put everything in one space. There's the demo that I did, which I showed this video yesterday on the live stream. Here is an introduction to the simulation. So this is what you saw yesterday. Here is the methodology, which is what we did today. And then this is the video for the data table, which is what we are doing right now, which I showed you how to do now. And then if you keep scrolling, this is how to do the graph. Okay. And if you keep going further, it gets into the reasoning part. And this is great, right? It says this is fake data. Don't use it or your lab or I'll know you copied. So yeah, there you go. But anyway, if you want to work ahead, if you've got your data in your lab already, which you can just honestly, for the number of loops, you're going to get the exact same numbers as me because you're kind of limited to only doing 1 to 4 loops, and your numbers are going to be the same as mine. Okay, so you've got your data here. You're just going to basically follow the directions in this video to graph it in Excel. Piece of cake. Right? The graph is relatively easy, and then all you're doing is you're just pasting it into OneNote. And then the only other thing that you have to do for this lab, at least right now, is to do the claim and reasoning. So it's not, honestly, I think this is a little bit easier than the other lab that we did, the Ohm's Law lab. All right. What questions do you have for me? Anything? Sarah, are you going to show up at midnight? It's going to be amazing. We're going to play some games and talk about life, give you guys some advice, life advice. I don't know. I honestly have no idea what we're gonna do. We what did we do last week? We talked a little about movies, right? No, that was the week before. Oh jeez, I can't even remember what day it is. It's horrible. Ugh. All these days run together. You know, it's been like over a month that we've been on e-learning. Over a month. It's insane. Absolutely insane. I would totally go back to school tomorrow if we could. I'm losing my mind. Absolutely losing my mind. I guess it's just you and Diamond. Anything else you want to talk about? Because I am done with physics for right now. There's nothing exciting going on in the news, unfortunately. Nothing other than just, you know, the normal depressing stuff that they keep posting about the coronavirus. Has anybody watched the new episode of The Tiger King? It's got Joe something that interviews some of the people after the documentary. Anybody seen that? Get out of here. Were you really on the news? Which news channel were you on? I'm going to look you up. Sarah News. What the heck is this? Did you know that this exists? Look at this. I gotta show you this. I know the spelling's not the same. Did you know that's a real thing? CBS. CBS Chicago. Let me see this. It'd be so cool if they have a video of you on the news. Let me see here. Why is it saying they're... It says their site is down. Hang on a second. What were you on the news for? I'm trying to see what's going on. Why I can't get to this website. Oh, yeah. You know, I remember seeing that story on there. Let me see if I can find the video. Let me see here. There's got to be a search on this page somewhere. Oh, here it is. Zoom bombing.
Only on to a new Zoom bombing attack, this time against high school students in Joliet.
Racial slurs and pornographic images appeared during a remote learning session, but how did it happen with new safety protocol announced just days ago? Tara Molina went straight to Zoom for answers.
Disturbing and upsetting. Words used to describe the hack or Zoom bombing incident we're about to tell you more about. Tonight, we took concerns to Zoom, and we're getting answers.
I just thought like that would never happen to us.
Ernest Krim, the history teacher and Black Student Union advisor at Joliet Central High School, is talking about Zoom bombing, something they just experienced firsthand.
They knew specifically that our group was all Black.
Targeted by hackers.
They were screaming like, you know, nail to the cross, nail to a cross.
He says the attack didn't stop there.
And then he started playing porn. And then at that point, it's like, all right, let's just get out.
Krim says they ended the call and reported the incident to administrators and the police. I took the incident directly to Zoom, who just announced new safeguards to prevent these incidents from happening.
You can see this new security icon that we've added.
So why didn't they work? A spokesperson told me updating your Zoom account is key and would have prevented this incident. Updated accounts feature new safety settings and defaults, like passwords for every call and waiting rooms, so a host can approve every person joining. There are new specific guides for teachers too, so only they can share content. But Krim's hope tonight? That this story inspires more than thoughts about safety, because he believes his group wasn't the only group targeted. Krim told me he made the mistake of posting their Zoom meeting link publicly, even though the meeting was protected. You can find more safety and security tips from Zoom directly. They're in this story on our website right now. Reporting on the Near North Side tonight, I'm Tara Molina, CBS 2 News.
Sarah, you're like a celebrity. I mean, that's a horrible thing that happened, but still, your picture was on the news. You're kind of a big deal. Can I get your autograph? You should sell your autograph. That would be really cool. I think you could probably make a ton of money on that. I don't know what you would even charge for an autograph. Like big time celebrities, you know, they'd be charging like $50, $60 for an autograph. You could probably charge at least that. Because, you know, being on the news is a big deal. I don't think I've ever been on the news. I'm not a big deal. But that was really cool. I mean, you know, it's horrible that it happened, but it's still, you know, there's nothing really else going on right now, and to be on the news for something that's not related to the coronavirus is, you know, I guess kind of a big deal right now. So, wow. Did you look at that link I posted? That news person? I mean, I know it's not spelled the same, but that's still kind of cool, right? You have like an actual, you should maybe apply to work for there. Sarah Carter taking back the story. She's a national and international award-winning investigative reporter whose stories have ranged from national security, terrorism, immigration, and frontline coverage of the wars in Afghanistan and Iraq. You should try to get a job there. You'd be like, my name's Sarah Carter, too. It's awesome. All right. Diamond, are you still here? Are you just waiting for chemistry? Yeah, don't do politics. Politics is a mess. You don't want to get in that. Diamond, are you still there? Diamond. I think she's asleep. She's probably watching shows. She's always watching shows. There's really nothing else to do right now. I've been playing a lot of video games. I got all my grading caught up, though. That's a big life achievement right there. Grading is horrible. I hate grading. It's like the worst part of being a teacher. Grading and calling parents. Calling parents isn't fun either. But I will say this. All the parents that I've had to call this year have been super supportive, and I appreciate that. It would be really hard if I had to call a parent of a kid that was like not doing anything in class, and then the parent was like, well, it's your fault. So it's good that we don't have any parents like that in our district. At least none that I've had to deal with. All right. Well, hopefully Diamond comes back, because I'm assuming she's here because she had chemistry questions, or maybe she was just lonely. But I'm going to give my chemistry people about 5 or 6 minutes to jump in, and then I'm going to go through some chemistry problems. It's going to be awesome. And I guess while I'm waiting, I will just do a quick check to see if anybody messaged me. Doesn't look like it. All right. So, Sarah, you got any big plans this weekend? Going anywhere fun? Like, you know, the sidewalk, down the block, to a different room in your house? I'm bored out of my mind. I really could. I mean, I would go anywhere right now. I'd even go to like Walgreens. Walgreens would be like Disney World right now just to get out of the house. I'm sure you can relate. We're all going crazy. All right. So Diamond, are you really not there right now? Did you really just sign off? You had enough physics and just called it? All right. Well, we're waiting for chemistry people to sign on if I get any today. The question of the day is, which professional athlete would you want to work out with? You're taking a trip to my bed. You're always sleeping or watching Netflix. I'm really jealous of your lifestyle. I had to call a student this morning to just check in because I hadn't heard from them, and they were asleep, and it was like noon. Their parent had to wake them up, and they did not sound happy. So, yep, make sure you do those Google Forms because I will call you. It's not fun for everybody. So just takes 2 seconds, just check in and let me know that everything's okay. So again, question of the day, which professional athlete would you want to work out with? If you could pick any professional athlete to be like your personal trainer, who would you pick? And in about 3 minutes, I will reveal my athlete of choice here. Might be able to guess it, maybe not. This person hasn't been, well, I guess maybe they're a commentator now. I've seen them on sports commentary, but not an active athlete right now, but still like in way better shape than I am, like a million times in better shape than I am. That sound right? Anyway, so that's the plan. And then don't forget, we have a Zoom meeting tonight at midnight. I'm super excited to do that. My wife is not super excited about that because she thinks that I'm going to wake her up. And I think I should just stay up all night so that when I jump in the Zoom meeting, I'm already super tired. It'll be great. Maybe, I don't know, maybe we should get like a Fortnite game going or something. We could live stream it. Or Minecraft. Mr. Jern, I think, has a Minecraft world for his class. We should get something like that going tonight. I think it would be pretty entertaining to play Fortnite on Zoom. What do you guys think? Would anybody play Fortnite with me? I got my first Fortnite win the other day. Squad win. My son basically carried me through that and got me a win. I had actually died in the game, and he had to, I don't know, you go to some van, some sketchy van, and they like bring you back to life or something. So that was exciting. All right, so about 2 more minutes, and then we'll get rolling with chemistry. If you are here, if you could just type in the chat. If you could pick a professional athlete to work out with you to be your personal trainer, who would it be? Lots of awesome choices out there, both male and female. Who would you pick and why? Hopefully, I'm gonna, you know what? I should probably set an alarm. Obviously, me. Yeah, you know, I've heard that you're really good at wrestling. You would be an excellent choice. I don't know that I'm tough enough to work out with you. I don't think I was in a jiu-jitsu club for a while. They did jiu-jitsu, judo, and they did some wrestling, and that was like the hardest workout I think I've ever done in my entire life. And when I was in the military, I did some pretty difficult workouts. I did the assault course in the Air Force. That was terrible. You're like wearing your full like set of combat gear, and you have to like go across the monkey bars and like do flutter kicks with combat boots on, which are really heavy. It was awful. And honestly, those wrestling workouts were probably the hardest thing I've ever done in my entire life. That's probably why I'm not doing jiu-jitsu anymore. So I'm gonna go ahead and get rolling here. So if I could pick any athlete to work out with, I would pick Frank Thomas. Was a huge player on the Chicago White Sox for like my entire childhood. His last couple seasons, he got picked up by the Oakland Athletics. But he was just a huge player on the White Sox. He actually retired with the White Sox. But just look at this, right? Just look at this. Look at his arms. They are so big. His arms are bigger than my legs. I mean, look at this. I got like nothing here. This is nothing. He could probably get me on some kind of workout regimen where I could pump up a little bit, okay? I mean, I'm built like a little tiny kid. All right, I have no muscular whatever on my body. Okay. Now that being said, you know, being a black belt in Taekwondo, being a 5th-degree black belt in Taekwondo, I can definitely hold my own. Okay, but still, you know, if I had to fight somebody like Frank Thomas, he would probably crush me just because he's so muscular. He just, you know, break me in half kind of thing. I am not anorexic. Okay, I do eat the same thing every day for lunch at school: peanut butter and jelly sandwich on gluten-free bread, a bag of chips, 2 applesauces, banana, and a protein bar. That's my lunch every single day. I eat the same thing every single day, and it's amazing. Never get too tired. I'm still at home. I'm still eating it. Actually, my wife critiqued my peanut butter and jelly making skills the other day. She said I'm terrible at it because I am not that picky. When I go to spread my jelly around, I just kind of just plop it on there, and like when you smush it, it kind of spreads the jelly apart. She is very particular about how the jelly gets put on. You have to spread it all around the bread before you mush them together. I think that's a little overkill, but yeah. What do you guys think? How do you make your peanut butter and jellies? So for chemistry, here is this week. This is kind of where we're working on. So Monday and Tuesday, we did some review of multi-step calculations. Yesterday, the quiz opened up, so you could have taken the quiz yesterday. The calorimetry lab was also due yesterday. Where have you been, Cecilia? I mentioned this. Okay? Like a couple times, like every day this week. All right, so the quiz is on. Yeah, no, I'm not doing a quiz. Got me messed up. Okay. Anyway, so the quiz. Now, all I'm going to do today on the live stream is go through a couple of questions similar to what you might see on the quiz. I'm going to pull these right out of the study guide for the unit. Don't worry, the test is not anytime soon. It probably won't be until not next week, but the following week. So I'd like to use this time to maybe go through a couple of questions. Hey, Denasia, go through a couple questions that might be on this quiz that are also on our study guide. So we're like, double dipping here. We're working on the study guide and reviewing for the quiz. All right, so I did push this out on OneNote. The study guide is also on my website if you want to pull it up. I believe I put a link to it in the post for today. Let me look. It's early in the morning when I do these, so sometimes I forget. But let me just check really quick. Let's see here. Bear with me for just a second. Let me make sure that I posted that today. I did not. So do this. If you want to follow along with me on your own paper, if you go to my website and you go to classes, chemistry, and then we're on unit 7. Down at the bottom of unit 7, you'll see the link for the study guide. I'm not collecting the study guide for points, but if you want to follow along with me, you've got the study guide, you've got the study guide key. So if you click on study guide, it'll pop up. You can just do this on your own paper. I know there are quite a few of you that are having OneNote issues. Like I think, Denasia, you were saying you were having OneNote issues. So if you're having OneNote issues, you can reach out to the help desk at school. They're still responding to issues. Actually, they've been very good about responding to issues. I've sent 2 or 3 people to the help desk in the last week, and they've been really quick. They'll like call you right away and get it resolved. If your computer's busted, you can actually just drive right up to the school, and they will swap out your computer for you. So that's what I want to do today is go through the review. It's in OneNote if you want to follow along with me. So let me pull that up. All right, and then let's go full screen. Okay. If you don't want to do it with me and you just want to kind of watch, that's fine too. Some people are just, they'll just like absorb it like a sponge. That's fine. Let me pull this up. So Denasia, how's work been lately? Let me pull up. Actually, let me make, oops, I lost it. Why would they put the maximize button right by the close window button? That doesn't make any sense. It's like they're trying to mess people up. If you're just a little too fast and it slides over, you're going to be closing the window instead. All right, so let's work through the first page. It shouldn't take us very long to get through this. And then we'll do some multi-step problems. All right, so first question says, label the diagram where the substance exists as a liquid, a solid, and a gas. First of all, if you look at the curve here, this one right here, is this a heating curve or a cooling curve? Heating curve or a cooling curve? Type it in the chat. Heating curve or a cooling curve? You have a 50% chance of getting this right. It is, nope, no, it is not a cooling curve. Okay, that's okay though. It's all right. I mean, you had a 50% chance, and you took a risk and you guessed. So I'm proud of you. This is a heating curve. The way you know it's a heating curve is because the temperature is rising. So you're starting here at this point, and you're ending here at this point. You're starting at a temperature of about 20, and you work up to a temperature of about 160. So it is a heating curve. If it were a cooling curve, you'd be doing, you would look something like this. That's a cooling curve. So we're starting at a higher temperature, and we're ending at a lower temperature. Okay? So we want to label our diagram as solid, liquid, and gas. So since this is a heating curve, we're going to start out as a solid from A to B. From C to D, we're going to be a liquid. And then from E to F, we're going to be a gas. Okay, so we did number 1. Number 2 asks for the melting point. So think about water. When water's melting, what's happening? You're going from a solid ice cube to liquid water. So on our graph, if you look at our graph here, we're a solid, and then we're turning into a liquid at this plateau right here. So at 50 degrees, we're transitioning from a solid to a liquid. So that's this point on the graph right there. Plateau is where you phase change. Plateau starts with the letter P. Phase starts with the letter P, so that's a good way to remember it. All right. Next question asks for the boiling point. So again, think about water. When water's boiling, what's happening? You've got a pot of liquid water on your stove, and it's boiling, so it's going from a liquid into water vapor. So you're going from a liquid to a gas. So on our graph, the plateau, don't panic about the exam. That's still probably 2 weeks away. All right. I know that this is the study guide. Again, I was just trying to double dip here and do a little bit of practice on heating and cooling curves, but I was using the problems from the study guide. All right. The boiling point is 100 degrees. Because if you follow this plateau over, it's right there at 100. Okay, next question says, at what temperature would the substance freeze? At what temperature would the substance freeze? So look at the graph and see if you can figure it out. Take a look at the graph and see if you can figure out what the freezing point would be. I can make this a little bit bigger. Oops. So at what point would this freeze? Take a look at the graph and see if you can figure it out. Sorry, Cecilia. What would you want me to do instead? You do a little dance? A little chemistry dance? That's about all I got. I don't have any moves. You're the one that signed up for this class. Remember that. Okay? You had your chance. You could have taken basket weaving or I don't even know what electives are offered. I just know that I don't get to teach any of them. So what is the freezing point? What temperature would this substance freeze? Cecilia, what temperature would this freeze at? It is going to freeze at the same temperature it's going to melt. If you think about it, water melts at 0 degrees. Water freezes at 0 degrees. So this plateau right here. So the melting point and freezing point are the same. And not to scare you guys or anything, but there is actually a winter weather advisory for tonight. Like, no joke. At 11 p.m. tonight until I think 1 p.m. tomorrow, we are under a winter weather advisory. We're supposed to get 3 to 5 inches of snow. That's absolutely insane. Insane, right? All right, next question. At what point does the liquid phase begin to increase in temperature? All right, so on our graph, we're a liquid from C to D. So this whole point here, or this whole segment here, is where we're a liquid. So it says, at what point does the liquid phase begin to increase in temperature? Point C or point D? Well, if you look here, point C, we're a brand new liquid. We just transitioned over from a solid. Now we're starting to raise our temperature. At point D, we've already raised the temperature of our liquid. Okay, so the answer would be point C. Next question asks, when is the kinetic energy increasing? Kinetic energy is any time your temperature is changing. Any time the temperature is changing. So on our graph, anywhere we have a diagonal is where our temperature is changing. Any diagonal on the graph is a temperature change, which is also a change in kinetic energy. So any of these three diagonals is a change in kinetic energy. So this would be AB, CD, and EF. So from points A to B, from points C to D, and then from points E to F. Those are all temperature changes. If I'm going too fast or if you don't understand something, please stop me and throw some questions at me. All right. Where is potential energy increasing? We are going to pause here because we haven't talked about potential energy. So we're going to skip number 7 for right now. But let's go down to number 8. Okay, and then we'll get into some calculations. Number 8 says, draw a heating curve for water. It tells us the melting point is 0 degrees and the boiling point is 100 degrees, which hopefully you knew that. Be sure to label both the x-axis and the y-axis and include the units. All right, so I'm going to make this a little bit bigger. I have no idea what that means. Oh, somebody's in the wrong chat here, I think. Okay. So let's go ahead and let's label our axes. Who told you we're not coming back in May? Is it on the news right now? School. I just checked the news. I don't see anything. Do you have insider information? Are we not going back in May, or is that just what you think? I know he's got our governor has a daily press briefing, and Mr. Nod has actually been following that every day. Just now? Hold on, we gotta pause for a second. I don't see anything. I'll have to look. Earlier? Okay. I hadn't seen anything, and they hadn't sent anything else out to us. So as soon as I know anything, I'll tell you guys. Okay, let's go ahead and finish this problem. So we need to label our axes. Okay, so the x-axis is going to be energy, and the units of energy are joules. The y-axis is always going to be temperature, and temperature, the units are degrees Celsius. You don't need to put numbers on the x-axis, but you do need to put numbers on the y-axis. Okay. Now, when you are labeling your y-axis, you need to be aware of your 2 points here, your boiling point and your melting point. You want to make sure that you leave space below your melting point and above your boiling point. So we're going from 0 to 100, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 boxes. Okay, so if we went by tens and maybe started at -10 and ended at 110, we'd be able to fit everything in. So this would be 10, 30, 50. Let me put this in here and I'll explain what I did. Okay, so we know that we are melting at 0 degrees, which is this point right here. And we know that we're boiling at 100, which is this point right here. So when I spaced out my axis, I made sure that I left space below my melting point and above my boiling point. You want to be able to show the other states. You want to be able to show all 3 states. So this is a heating curve, so it's going to look something like this. Yeah, so Denasia, tonight at midnight. That's technically Friday morning. Okay, so here is our curve. And we're done. We don't have to do anything else, but I just want to quickly throw on here really quick that we are a solid down here, we're a liquid here, and we're a gas at this last spot up here. Okay, it's very important that you're able to read these curves. Okay, so you know this is a heating curve. If the curve looked like this, that would be a cooling curve. You need to be able to know that the diagonals, so these parts right here, are where you're in the solid, liquid, or gas state. And then you need to know the plateaus, the flat parts of the graph, are where you're changing states. That's very important. If you didn't know that, it's okay because we're not testing tomorrow, but you should definitely go back and work through those sections where we talked about the interpreting heating and cooling graphs. Okay. All right, I do want to get to let's do at least one single step before we call it a day here. So this one right here, this one right here would probably be a good one to start with. Let's do number 11. Okay, so this is a single step problem here. It says, how much heat needs to be applied to 100 grams of water so that it heats up 2 degrees Celsius? I hate this class. Not going to school is great. It's a little bit easier, like being able to do school like this. You know, I bet you more than half of you are probably wearing pajama pants right now. I'm a little jealous if you are, because I'm not wearing pajama pants. Grace says, what day is it? I think today's Thursday. I'm not sure. All the days just kind of blur together. All right, so let's do number 11, and then we'll wrap up here. Okay. So anytime you're doing a temperature change, you're going to use the equation Q equals mc delta T. All right. In the question, we are told that we have a mass of 100 grams. Our temperature change is 2 degrees Celsius, and it even tells us the specific heat of water is 4.18. So 100 grams is our mass. C is your specific heat, which is 4.18. And then, I forgot my units. I'm a terrible teacher. Joules over grams degrees Celsius. And then my temperature change, which is 2 degrees Celsius. So 100 times 4.18 times 2 is 836 joules. So that is a single step problem. If you want to do the rest of these for practice right now, number 12 and 13 are also single step problems. And then let's see, how much time have we got? We got 7 minutes. Let's see if we have let's look at, I don't think I'm going to have enough time to finish these. Well, let's do this. Let's go down to this one right here. Okay, so this is number 17. So this is similar to multi-step. This is just kind of breaking down like the steps of a multi-step problem. a lot of people that struggle with multi-step problems don't understand what you're even supposed to be doing, which, I mean, that may apply to anything you do in chemistry, like, what am I doing here? But this isn't very apparent. So the analogy that I keep giving for multi-step problems is to kind of think about it like Google Maps. Okay, so if I'm going from like, if you're going from like point A to, point D, you want to know the total energy it takes to go from those points. So think about how Google Maps works. Okay, so let's say you're going from point A to point D, and those lines on your graph are your different streets. Your Google Maps is, when it goes to figure out how far you're going, it figures out how far you're going on this street, then it figures out how far you're going on this street, and then it figures out how far you're going on this street. So we're kind of doing the same thing when we do multi-step problems. We have to figure out how much energy it takes to go from points A to B, and then how much energy it takes to go from B to C, and then how much energy it takes to go from C to D. Okay, so that's pretty much all we're doing. So for A to B, anytime we're changing temperature, we're going to use the equation Q equals mc delta T. For AB, since we're a gas here, we're going to use the specific heat of a gas. From C to D, you're a liquid, and then from E to F, you're a solid. Okay, so B to C, that's this part right here, it's a plateau. Plateaus are phase changes. So anytime you use a phase change, you're going to use the equation Q equals M, and then it's either going to be the heat of vaporization or the heat of fusion. Anytime you're going from gas to liquid or liquid to gas, it's the heat of vaporization. It's kind of easy to remember because if you think about like if you're boiling water on your stove, it's evaporating. Like vaporizing, evaporating kind of is similar. So think of it like that. All right, from C to D, so this part right here, we are changing temperatures. So we're going to go Q equals mc delta T. From C to D, we're in the liquid state. So C is going to be liquid. All right, from D to E, we are on a plateau. Plateaus are phase changes. So Q is going to be M, and then it's going to be the heat of fusion. Fusion occurs anytime you're going from liquid to solid or solid to liquid. Okay, and then the last one, from points E to F, you're on a diagonal. Diagonals are temperature changes. So this is going to be mc delta T. From E to F, we're a solid, so we're going to use the C of solid. And that's it. So anytime we're changing temperatures, it's Q equals mc delta T. Anytime we are on a plateau, we are going to be using the heat of fusion or the heat of vaporization. What questions do you have on these? We'll do some more of these next week. Actually, no, wait. We won't. Will we? We won't. If you missed yesterday or if you missed the day before, I did post the live streams and I worked through some more multi-step problems. But if you haven't taken the quiz yet, you do need to know how to read the graphs. So like this stuff would be good to look at. You do need to know how to read the graphs. You should know how to draw one of the graphs. You should know how to do single-step calculations, and you should know how to do multi-step calculations. Okay? You just have until the end of the day tomorrow to take the quiz. If you're struggling with this stuff and you feel like you need some extra help, I don't have a live stream tomorrow, but if you would like some extra help, I'm happy to do one-on-one tutoring. I actually had a student that I worked with this morning, and we went through some multi-step calculations, and she told me that she felt like it really helped. So if you really are struggling with these and you have no idea what you're doing, just when we're all done here, just send me an email and let's coordinate a time tomorrow where I can do a Zoom tutoring session. Happy to do that with you. You don't even have to show me your webcam. I'll be able to hear you, but you'll be able to see my screen so I can go through some more of these problems with you. Okay? So that's all I had planned for today. I just want to remind you guys that tonight I'm doing my my Zoom check-in. It's going to be at midnight, and it should be a lot of fun. I'm anticipating we'll have quite a few people because I'm under the impression that most of you are staying up at night, which, I mean, I probably would be too if I were in your case or in your shoes. I'm an old man, so I would go to bed every day at 8 o'clock if I could. So if you're able to make it tonight at midnight, that would be great. I emailed everybody out the information. I don't post it publicly. It's always via email so that we don't have any issues with security. So if you didn't get that email, shoot me an email and I'll send it out to you again. But you should have all the information you need to join. I look forward to seeing you guys tonight. And that is all I had for you. So I'm going to go ahead and sign off for the next 10 hours, and then I will see you back for